Hey guys, Absolute 5 here again. So today's lesson is going to be about the quotient rule. So we covered the product rule, now the quotient rule. Funny thing is the product rule is similar to the quotient, but not, when I say similar, just like it looks similar, like the top part looks similar, but at the same time it's completely different at the same time. Like this is what I mean. Well, let's first figure out what is the quotient rule. The quotient rule is, and ideally, it's this definition here. Obviously, if you hear the word quotient, you're going to think of some sort of fraction or some sort of form of division. So if f and g are differentiable, then this is possible. When you take the derivative of a function x over function g of x, you get g of x times the derivative of f of x minus, the difference here is that there's a minus and there's another difference as well, f of x derivative of g of x all over g of x getting squared. Now, like I said, the only thing I thought the product rule and the quotient rule was similar was just this top part and that the signs change. It's not the exact same format because the product rule has f of x, then g of x, plus g of x, f of x, the derivative of f of x. So that's why I thought it looked similar, but other than that, they're not really the same. Long term, they're not really the same, sorry. So what this is saying is when you differentiate two functions as a ratio or as a fraction, this is what you apply. Now granted, not all the time you should use this the second you see a fraction. I'd recommend trying to use some algebra to pull out some variables, do some cancellations, some factoring to cancel out some of the terms. So then you're just left with a regular function to take the derivative, and then you'll be fine. You only use this when you cannot absolutely factor, okay? So let's see an example where you have to use this. So let's say let y equals x squared plus x minus 2 all over x to the third plus 6. We can see the top part, it didn't look too factorable. It probably is factorable, but I'm not going to check. But this is definitely not factorable. X to the third with this is a no-no. So let's take the derivative. Y prime. So remember, the top part of the function here is going to be f of x, and the bottom is going to be g of x. These are two separate functions. So f of x, so remember the derivative, so first it's g, x to the third plus 6, times the derivative of f, which is going to be 2x plus 1, minus f of x, which is x squared plus x minus 2 times the derivative of g of x all over g getting squared. Most cases you don't have to actually for this out because it's a mess. So you can just leave it like this in this situation here. So let's now do some algebra. We have to do the for method. So we're going to say x to the third times this, I get to 2x, so I get 2x to the 4 plus x to the third, and then I get plus 12x plus 6. So I wait with the negative sign, meaning I'm just going to do this first, and then I do multiply the negative because I don't want to make a mistake with the sign error. So x squared, well, 3x to the second times x to the second is 3. X to the fourth, add the exponents, come on. Then I got 3x to the third plus, negative x squared. Close the parentheses. x to the third plus 6 getting squared. So let me erase the top because I gotta continue this up top here. So when I rewrite the next line, right, y prime is going to be 2x to the 4 plus x to the third plus 12x plus 6. I distribute the negative now. I get negative 3x to the 4 minus 3x to the third minus 6x, sorry, plus 6x all over x to the third plus 6 getting squared. So if you notice this line here, I didn't distribute the sign, the top part I did. So let's erase the next line here. So now, if we can, now all we have to do is simply combine like terms. So we can combine 2x to the 4 minus 3x to the 4th. I get negative x to the 4. So that's exhausted. X to the third minus 3x to the third, that's negative 2x to the third. So that's done. And I can't combine anything else because x squared, there's nothing for 6x squared to combine, plus 12x plus 6 all over x to the third plus 6 getting squared. And that will be your answer here because there's nothing else you can do. So as you can see, the process is pretty tedious, it's pretty annoying, and you gotta be very careful with your multiplication and also being able to recognize the signs. That's why I say you only use this rule if you absolutely have to use it. It's not too bad, it's just, it can get complicated quickly. That's why you have to be careful when you use this formula pretty much. Okay? So, like I said, use this if you absolutely need to. So that's the lesson for you guys today. That's the quotient rule. If you have any questions, if you have any questions or concern about math or anything, be sure to leave a comment down below. And if you like, be sure to like, share, and subscribe to my channel. And if you like the content I'm providing you guys, be sure to hit the bell button next to the subscribe button. And that's basically it so this has been Absolute 5. I'm Roger Palomino, and math is infinite because there are infinitely many possibilities.